physical pendulum is an oscillating solid body. For example, this is called a physical pendulum. Rigid body oscillating, it is called a physical pendulum. It is not a simple pendulum. It is called a physical pendulum. Okay? Or this is a solid rigid body, this is oscillating. Now this makes a physical pendulum. This is a physical pendulum. Okay? This is oscillating and it is a physical pendulum. You have to find its time period. Okay? Or this type of thing. This is also another rigid body and it is oscillating. It is a physical pendulum. So we have to find the time period of physical pendulum. So physical pendulum is a rigid body that is oscillating. I am showing here a rigid body. Okay, the body is suspended from this. But that is connected to a string. String is not rigid. String is not rigid. Okay, from physical pendulum we'll move to simple pendulum. Physical pendulum is actually a general pendulum, a general situation, and simple pendulum is a specific case of a physical pendulum. Okay, so first you understand this, then in the next question only I will tell you, using the time period of a physical pendulum, obtain the time period of a simple pendulum. So what is a simple pendulum? A specific case, and this is more general. Okay, so I have shown a rigid body. This point is called point of suspension. This is the point of suspension, and there is another point in it, which is CG, center of gravity of the body. This is center of gravity of the body. Okay, can the body remain in equilibrium in this position? Obviously not. It cannot remain in this position. The body will oscillate about this line. Okay, it will oscillate about this line. The length of this is important. This is D. Mass of the body is M. Okay, so this is oscillating. This body is oscillating. A rigid body that is oscillating. Okay, how will you get its time period? Means how will you start? Free body diagram I have already shown that through this point the force which is acting through this point is mg through this point mg, weight of the body is acting, and this angle is suppose angular displacement theta. So how will you start? How will you start? Obviously torque, and that torque is of restoring nature, because the torque of mg will bring the body back to this, then as it will go to the other side crossing the mean position, as it goes to the other side again it will come take the body backward. Okay, you can consider this simple example. Okay, so definitely there is a torque which is bringing the body to this position, then because of inertia the body crosses, as it crosses again that torque brings it back. Okay, so this torque is restoring torque. Restoring torque is analogous to restoring force. Restoring force in linear motion, in translational motion, restoring torque in angular motion or rotational motion. what is the formula for restoring force? Restoring force. Restoring force. Fr equal to m into acceleration m omega square x. So what should be the expression for restoring torque? So you have studied rotational dynamics in detail. M should be replaced by I. Omega square. X will be replaced by theta. Good. So tau r equal to I omega square theta. Okay. Now there is omega square in this expression. And what is omega? 2 pi by t. So if you can find the restoring torque, which I hope you can, because mg into perpendicular distance you know how to find. If you can find restoring torque, moment of inertia is known to you, because the body is given, its moment of inertia is known. If I give you a scale, then you know it will be ml square by 3, okay, or ml square by 12, depending on the axis of rotation. That is I is known. So tau r you can find, moment of inertia is known to you, theta. Okay, so theta means tau r equal to I omega square theta. From that, from this expression, you will see that theta on the right hand side and another theta will appear on the left hand side. They will cancel, and you will get omega. So let us start. Okay, so restoring torque. Restoring torque when angular amplitude equal to theta, when the angular amplitude is theta, tau r. So prepare yourself for this question. Tau r, I will not write, you tell. Force into perpendicular distance, force is visible. Now perpendicular distance, some of you are really expert in finding the perpendicular distance. So can you see the perpendicular distance here? Perpendicular distance of the line of action. Okay, theta, d cos theta, and this one is d sin theta. mg into equal to mg d into, I will write theta and then I will write something in bracket. You know what I will write. For small oscillation. For oscillation with small amplitude. Sin theta less or equal to 4 degree, sin theta equal to theta. In what unit? Radian. Okay. So mg d into theta for small angular amplitude, theta, that means theta less or equal to 4 degree, sin theta equal to theta. I think you have already got your answer. Hence, then we write, since tau r equal to I omega square theta, tau r equal to I omega square theta, hence I omega square theta equal to mg d into theta cancelled, or omega square mg d by I, or omega equal to root over mg d by I, okay, or t equal to 2 pi root over I by mg d. Formula, important formula, very important formula. Time period equal to time period of oscillation of a physical pendulum is 2 pi root over I by mg d. What is d? Write separately here. d equal to distance between, what is the distance between point of suspension and D equal distance between point of suspension and center of gravity, CG. Okay, so you understood this discussion? You will remember this formula. What is I? I have already told you that moment of inertia has no meaning unless you specify the axis of rotation. So whenever someone will ask you what is I, you will tell moment of inertia about axis of rotation. Okay, if this thing oscillates about this, what is the formula for I? mn square by 3. But same thing oscillating about the midpoint and oscillating about some point which is neither end nor mean. Which theorem?
Parallel
axis theorem. Good. So let us solve the problem. So a meter scale means its length is 1 meter. This is the meter scale. This is suspended from 30 centimeter mark . 30 centimeter mark. This is 0. This point is 0. 30 centimeter. 30 centimeter. Then this is 50 centimeter. 50 centimeter. This is 100 centimeter. This point is CG. CG. This is point of suspension. Point of suspension, and this oscillates like this. Okay, T equal to, we'll use the formula I by mgd. I about axis of rotation. This is the axis of rotation. Okay, once again I will explain parallel axis theorem. This point is, this is what? Cm, and when the body rotates about this axis, its moment of inertia is ICM. Then what is parallel axis? An axis which is parallel to this axis. An axis which is parallel to axis through CM. This is parallel axis. And this is called PP dash. Okay? When the body rotates about this. Okay, have you got my point? When the body rotates about this axis, that means this is the body, it is now rotating about this axis, outside the body. IPP dash for rotation about this axis. IPP dash. IPP dash equal to ICM plus M into D square. ICM for the scale. ICM means about center of mass, that is ml square by 12. ml square by 12. Moment of inertia when the rod rotates about axis through CM, that is ml square by 12, plus m into, what is the distance between distance between the two parallel axes? 20 centimeter. Okay. Okay, and what is the value of L? 1 meter. So m by 12 plus m by 25 equal to how much?
37 m by
How much?
12 into
37.
37 m by 12 into 25.
37 m by
12 into 25.
means 300. 300. This is IPP test. Then, hence, time period equal to 2 pi root over I 37m by 300 divided by mg into d. D is the distance between center of gravity and point of suspension. Means that is 0.2. Okay. Mm cancelled. Equal to 2 pi root over 37. Check my calculation, okay? 0.2 equal to 1 by 5, then 5 into 37 by 300, 2 pi root over 37 by 60. Am I correct? Calculation ठीक है? Divided by G. 6. Okay? That means 10 pi by 5 root over 37 by 6.